Charlie, where are you going?
I can't find my parrot.
You mean Polly?
Yes, Polly, she is gone. Polly's gone.
So polygons, huh? Polygons. Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, dodecagon, and then anything past 12 is just an n-gon. So 123 sides, 123 gon. So polygons. So I guess I'm standing right next to a polygon. This right here, stop sign. 8 sides. Suppose that'd be an octagon, huh? And it would be a regular octagon because all the angles and all the sides are congruent. I bet you've always wondered what the sum of all the interior angles of an octagon is, haven't you? Well, since you asked, I would love to show you how to find the sum of the interior angles of a stop sign. To do that, you use this formula. Okay, so you take the number of sides minus 2 and you multiply it by 180. So I'm going to take the number of sides of a stop sign, which is 8, subtract 2, and then multiply that by 180. So 6 times 180 is 1080 degrees. So the sum of all the angle measures in a stop sign is 1080. I bet you are always wondering that. And even better yet, I bet you've always wondered what one angle measure is. Have you? Let's check it out. Well, I'm glad you asked. To find the measure of each individual angle in a regular polygon, you're going to use that same formula, so you'll find the sum of all of the angle measures inside of that regular polygon, and then you divide by the number of sides. Okay, so we're going to do the same thing we did. We're going to take n minus 2 times 180. Okay, so we're going to take the 8 minus 2 times 180, and then we're going to divide that by 8. So we take the sum and we divide it by each individual, we divide it by the number of sides to find each individual angle. Okay, so we take 6 times 180, which we said was 1080, divided by 8, and we get 135 degrees. So if you don't believe me, you can go to any stop sign and take a protractor and measure the angles. Each angle would be 135 degrees. Should we see if that's right? So we'll measure this very carefully. Hey, it looks like we were right. 135 degrees. Good job. Just need a little inspiration. I don't know. Is there around here for inspiration? I wonder what this is. All right, let's just see what this is. What do you call an urgent message sent to an alternate universe? A parallelogram. This is a parallelogram. The definition of a parallelogram says that opposite sides are parallel. Opposite sides are also congruent. Opposite angles are congruent. And consecutive angles are supplementary. So if this angle is x, then this angle is 180 minus x. The diagonals of a parallelogram bisect each other. All of the properties of a parallelogram at the same time. Okay. What do you call an angle that got in a car crash? A rectangle. A rectangle, you get it? The definition of a rectangle is that it is a quadrilateral with all right angles. In addition, the diagonals are congruent. But it's still a parallelogram, so all the other rules apply. What was the geometry student's excuse for being tardy to school? He got on the wrong bus. Wrong bus, wrong bus. We have a rhombus. The definition of a rhombus is that it is a quadrilateral with all congruent sides. Also in a rhombus, the diagonals are perpendicular, but it's also a parallelogram. So all those rules apply as well. What do you call an equilateral quadrilateral? Oh, I bet this one's really funny. A square! Huh? You're expecting something funny, huh? But no, a square is just an equilateral quadrilateral. And a square is basically a rectangle and a rhombus. All of the sides are congruent, and all of the angles are 90 degrees. So then anything that was true about a rectangle and a rhombus are true. And a parallelogram. Getting a kite stuck in the tree isn't my favorite thing, but it's up there. So yes, a kite is a geometric figure, believe it or not. Okay, so the definition of a kite is that there are two sets of consecutive congruent sides. These two are congruent, these two are congruent. Okay, and if you look, there's this diagonal and this diagonal. They are not congruent, but they are perpendicular. In addition, there is exactly one pair of opposite congruent angles. These two angles are congruent, okay? This diagonal is a line of symmetry, so that means that these two angles would be congruent and these two angles would be congruent. But this right here is not a line of symmetry. Okay, so the same is not true of these pieces of angles. This diagonal does not bisect these angles. So there's a kite. What does Charlie use to try to catch Polly? Hey Charlie, what you doing?
I'm building a trap for Polly.
So what does this do?
It catches birds.
It catches Boyds?
Birds.
Oh, so it's like a trap of Boyd.
Birds.
Oh, okay, so like a trap of Boyd.
Birds.
Trap a bird. Trap a bird. Do you think it'll work?
Uh-huh.
You think it'll catch Polly?
Uh-huh. When is she coming?
I don't know. What do you think? Do you think she'll come back?
Yeah, I hope so. I miss her.
Oh, a trap a Boyd or trap a bird. But he says trap a Boyd, so trapezoid. Yeah. A trapezoid has exactly one pair of opposite parallel sides. Okay, these are called the bases, and the other two sides are called the legs. Okay, in an isosceles trapezoid specifically, the legs are congruent. Okay, so we still have one pair of opposite parallel sides, but then the legs are congruent. Okay, so here's something called the trapezoid mid-segment theorem. Okay, and what that says is that if we have a segment that connects the midpoints of the two legs, then that's called the mid-segment. Okay, the mid-segment. And the mid-segment is parallel to the two bases, and it's also equal to the average of those two sides. So let's say that this side is 4 and this side is 8. Then to find the length of the mid-segment, we would find the average. So the mid-segment would be 6. So let's do a couple of problems to see if we understand all of these properties of these quadrilaterals. Okay, so let's start with this rectangle. And we have to remember all of the properties to help us figure out what to do. Okay, we need to find x. There's x's everywhere. And so if you look here, we know in a parallelogram that the diagonals bisect each other, right? So let's put these two equal to each other. We'll go 2x plus 4 equals 4x minus 6. Okay, and so then I'm going to subtract my 2x. Okay, 4 is equal to 2x minus 6, so that's 6, that's 6. I get 10 is equal to 2x. X equals 5. Okay, so x equals 5. Okay, we didn't really care here. All we know is that we have to find AB. Okay, so we're going to plug 5 into x here, so we'll take 3 times 5 and subtract 2, so we get 13 for the length of AB. All right, let's move on to this problem right here. Okay, and this is a rhombus. Okay, we need to find x, we need to find the measure of angle CDA, and we need to find the length of AB. So that's a lot of stuff to figure out. So let's see. How are we going to find x? We've got an x here and here. Okay, this 18x. This 18x is this angle right here. So this angle is 18x degrees. Any ideas? What's true about the diagonals in a rhombus? Yes, they are perpendicular. So we're going to go 18x is equal to 90. Okay, so we divide by 18. X is equal to 5. Okay, so we found the first part, x equals 5. Okay, now we need to find the measure of angle CDA, and we can look at just this triangle right here. Okay, we know that this angle is 90 degrees. I'm just going to take that off and make this 90. So we've got 90 and we have 35, right? Oh, So we can figure this out, right? Because it's a triangle. So we could go 90 plus 35, and we get 125. We can subtract that from 180, and we get 55 degrees. So the measure of angle CDA is 55 degrees. Okay, and we've already found x. We said x was 5, so we can plug it in here. Okay, so 3 times 5 is 15. 15 plus 4 is 19. We did it. Excellent. Good job, guys. I think you're ready to go.
It got Polly. Yay, Polly. Yay. I found you. I missed you. I love you. That was Woo. Wow, you're